Simcenter FLOEFD is a front-loading CFD tool that is fully embedded in the most popular CAD programs such as Siemens NX, Solid Edge, and etc. In this demonstration, we will be looking at the flow simulation capabilities within NX using Simcenter FLOEFD. We have an intake manifold here. The air goes into the air intake, travels through the throttle body into the intake manifold, and from there into the engine through the cylinder head. Through the internal analysis, we can get a feel for what's going on inside of this particular model. Using the FLOEFD check geometry, we can visualize the air region within. The blue volume is the air occupation region, and the complex shape can be seen. This part does not have to be created manually. FLOEFD generates this automatically for an internal analysis. Looking at the general settings, we can see this is an internal analysis with air set to be the default fluid. Environmental pressure boundary condition is set on the intake lid, and the static pressure condition are set on the lids of the air outlet, so that the pressure drop of 0.05 psi is driving the airflow. This model is pre-solved, and we can look at the airflow in the intake manifold. Let's first examine the mesh. FLOEFD Smart Cells technology is robust and can easily capture arbitrary and complex geometry. As a result, the meshing process is completely automated and requires minimum manual user input. Next, we can take a look at the result through the cut plot. We can see the airflow via the vector plot and also the pressure at this particular plane. As expected, the pressure drops as the air is exiting. We can also use the surface plot to look at the pressure for the complete air domain. To visualize the airflow, we can use the flow trajectories to learn how the air travels through the intake manifold. We can see there is some circulation here. Since we have set some goals before the simulation, we can now view the numerical results. This can be also exported to Excel for further analysis. Taking the advantage of being fully embedded in NX, we can perform parametric studies to simulate different design geometries, constraints, or modeling parameters. Here, we have an example on how the angle of the throttle valve will affect the flow rate at the exit. As expected, when the throttle valve is closing, there is less air flowing through, and the volume flow rate decreases. Using FLOEFD, it is very easy to compare and quantify different scenarios. Finally, let's modify the model so that each exit has a different pressure profile versus time. The transient study takes a time period of 0.5 seconds. Using the Transient Explorer, we can see how the pressure changes across time. We can also use the ISO surface plot to see where in the intake manifold has a pressure of 14.69 psi with respect to time. Similarly, here's the ISO surface plot on the velocity of 2.5 meters per second, colored by the pressure across the computational time. Fully embedded in Siemens NX, Simcenter FLOEFD keep pace with the speed of design and minimize disruption to the workflow. In addition, FLOEFD lets engineers fully explore the design space and only proceed with the strongest concept further down the chain. And FLOEFD reduced the design group reliance on the CFD analysis group, which is usually overstretched. This way, the analyst can focus on solving the most complex multi-physics problems.